I made a little video here that's titled Finding Average Velocity, and I did that because it's a common mistake that people tend to think of average as the midpoint between two other points, and that's kind of a naive and not sufficient definition of average when we deal with some of these physics problems. So let me give you an example here. We're going to practice a little of the calculus that you may have seen in another video of mine. But suppose we're given a position function. I'm just kind of making this up, and maybe it's the position is given in meters as 5t cubed minus 3t squared plus 5t. And it's, again, kind of a cryptic way of describing a position, but you could imagine putting this on a graph or making a series of little dot diagrams. But that's just how you have to recognize that in this level of physics and kinematics. And the question might be to find the average velocity between 1 second and 3 seconds. Now, the naive approach that you might take is say, well, that's just going to be whatever the velocity is at 2 seconds. But I want to demonstrate why that doesn't work. But here's a good practice at using calculus, because our first step would be to maybe find out what the velocity function is for this. And that's a matter of taking the derivative of the position function with respect to time. We say it's dx dt in the language of calculus. And I'm not going to go through how I'm getting this because that was a couple other videos that I made. But the function would be 15t squared minus 6t plus 5. That will give you the velocity in meters per second at any particular time given in seconds. So let's look what happens when we examine the velocity at 1 second, and the velocity at 2 seconds, and the velocity at 3 seconds. And this is just a matter of using our trusty calculator here. So maybe I'll show it in the display just for the first one. I've done these calculations already. You can kind of trust me on this, but maybe I'll do the last one here, the velocity at 3 seconds. So it would be 15 times 3 squared minus 6 times 3 plus 5. And that gives us 122 meters per second. And the other two, velocity at 1, this is one you could almost do in your head, would be 14 meters per second. And in the middle here, it's 53 meters per second. So one thing I want you to notice is that the velocity at 2 seconds is not halfway between the velocity at 1 and 3. The midpoint of these is actually 68 seconds. Or I'm sorry, meters per second, I should be saying. So that's not the midpoint of that, and that's because this is not a linear function. I mean, if we graph this, clearly that's a parabola, and so there's be no reason to expect that it would be the midpoint. So if that doesn't work, you might say, well, how will we find the average velocity? And for that, we're going to go back to the very definition of average velocity. Average velocity, I'll write it this way. Sometimes it's written as v bar, the velocity with a bar over it. But the definition is it's the displacement, or the change in the position during that time, divided by the amount of time that that takes. So what do we mean by the displacement? Well, that is the position where it ended up compared to the position where it started, or symbolically, x at 3 seconds minus x at 1 second. And then divided by the 2 seconds worth of time that's between 3 and 1. So this is actually evaluating not the velocity function, but we go back up here and evaluate the position function at 3 and at 1. So again, I've done these. You can trust my calculation here. The position at 3 seconds is 123 meters. And the position at 1 second was at 1 meter. And that displacement took place over 2 seconds. So that means we have, let's see, what's the difference here? 116 meters covered in those 2 seconds. And if we divide those, we get 58 meters per second on average. So that kind of makes sense because we were going positive 14 at the beginning. We're going positive 122 at the end. Halfway through, we're going 53. So it kind of makes sense that we're going to be going somewhere in the neighborhood of that midpoint. We were going positively the entire time. If we looked at the parabola, we could tell why that is. But you're not going to be able to get the value by looking at the velocity function. It's actually the position function. What would be an interesting question now is, at what time here between 1 and 3 seconds are you actually going 58 meters per second? Or in the language of kinematics, we would say, when is the instantaneous velocity equal to the average velocity between those two? Now, I'm not going to do that, but that would be an exercise that you might want to do, or you might be asked at some point. I think this is long enough and hopefully helps clarify some things that may have confused you in a kinematics problem. And we'll kind of head that off before it happens. Thanks for watching.